Jai Hind, my dear students. As we have been discussing about the chapter metals and non-metals, and we have already dealt the topics, that is the different chemical properties of metals and non-metals. So I hope all those properties are clear to you, and you are able to make out the products, and you are able to understand all the properties which I have discussed in my classes as well as in my videos. So today I'm just going to talk about the next and the last topic for this chapter, and that is the bonds. And before we talk about, let us first of all understand how is it related to our everyday life. Now, suppose just recall those days when you were taking admission in a new school. So gradually you form your friends. So these bonds are actually the same. So what is the important thing here that we are going to talk about, that in terms of a metal or a non-metal, there is an interaction which creates a kind of interaction between them. What is that thing we will discuss in the next few slides. So that interaction is only called as a bond. Okay, so in this particular video, we will be talking about the types of chemical bonds, and I would just tell you what are the different types of bond. We are going to talk and focus on to only one type of chemical bond, and that is the ionic bond. As like you form a bonding with your friend, similarly there is an interaction between the two different atoms here in a specific condition, and that is how there is an interaction formation, there is a bond formation, and that is what is called as the chemical bond. So in chemistry we say that the interaction which is created between any two substances is called as a chemical bond. So as you all can see on your screens, the chemical bonds here. So the types of chemical bonds, there are generally two basic type of bonds which you will be required to study, and that first one is ionic bond and the second is the covalent bond. So covalent bond we will be discussing in the next chapter, that is carbon and its compound. But today we are going to discuss about the ionic bond in more detail. So as you all can see this picture, this picture is depicting some of the things which are related to the ionic bond, and the second is somewhat related to the covalent bond. So in the first picture you can see there is a complete donation of a particular substance, and that is what is called as the electrons, whereas we find in the second case there is a sharing of the electrons, with which there is a formation of an interaction called as the covalent bond. So let us see the first type of chemical bond, that is the ionic bond. If you pay attention on this phrase which is given here, I just want you all to just read this once. Take this and be mine. So what is this which is required to be taken by one of the atom? It is actually the electron, maybe 1, 2 or 3, and the other who is ready to accept it will be the another atom, and therefore there will be an interaction because of this transfer of electrons, and then it will be called as the ionic bond. Okay, in this module you can see, in this particular slide you can see that if there are two atoms A and atom B, and there is more stronger forces of attraction from atom B and there is a lesser one from A, so that means there is a sharing of the electron from both of these, but the power or the electronegativity difference is more, because of which one atom is able to attract it or pull it towards its side more strongly as in comparison to the other one, and the other becomes a weaker in its electronegative character, and this kind of bond is basically where the sharing of electron is done, is called as a covalent bond. Why is it called as covalent bond? Because it is the valence electrons of both the atoms, or those atoms which are involved in this bond formation will be taken up, and that's why it is called as covalent bond. In the case of ionic bond, you will find the electron transfer will be taking place. One atom is transferring the electron to the another atom, and the other one is completely accepting and receiving that. So here, as we have discussed just now, the name is bond of this particular bond, and it's taken and not shared, as like in the case of the covalent. So let us see how does these ions and ionic bonds are being formed. So from the name itself, you can understand ionic bond, which are also termed as electrovalent bond. Okay, so they are actually formed because of the presence of ions or the formation of ions. So ions, as you all know, that whenever an atom loses or accepts any number of electrons, it acquires a positive or negative charge on it, and because of which what happens, it becomes a charged particle, and this charged particle then is termed as an ion. If it is positively charged, it is called as cation, and if it is negatively charged, it is called as anion. So when an atom loses an electron, it loses a negative charge and becomes a positive ion, and when an atom gains an electron, it is gaining a negative charge, which is an extra charge, so therefore it becomes a negative ion. So this positive ion is called as cation, and this negative ion is called as anion. So here, when like as in this picture, you can see if there is an atom which is about to lose an electron, so once it has lost the electron and the other is there to accept that electron, and initially they both were neutral, there were no extra charges, the charge on them was zero, but as soon as any number of electron is lost, it becomes a positive charge and the other becomes the negatively charged particle. So this is the simple representation how you can show that atom with a spare electron. What does it mean by spare electron? Means the electron which is creating a kind of instability, or which is not leading it to gain the electronic configuration of its nearest noble gas. It will either try to lose the electron, or maybe it will try to accept the electron, and that is how it will go for the selection whether it wants to donate it or it wants to accept it. So there is an atom with the spare electron, and definitely it has to be the valence electron. It will be given away to some other atom which is in a requirement to accept that electron for becoming stable. So in class 9th, you all have studied about the octet law. It says that there should be 8 electrons in the outermost shell or the valence shell. So here, if you can see this particular case, this is lithium. So in lithium, when there is 3 electron, it will try to lose out this 1 electron rather than accepting 7 extra electrons, and it will try to get the electronic configuration of its nearest noble gas, which is helium, which has 2 electrons in its valence shell. Therefore, it tries to lose that 1 electron which is extra for it, and then after what will happen, it can be accepted by any one of the atom which has 7 electrons in its outermost shell, so that it can complete its octet after attaining that 1 electron with it. So that is how it will go on in the case of the ionic bond. As soon as this process of transfer and acceptance get over, you will find that the atom which has donated or transferred the electron, it will become positively charged cation, and the one which has accepted it, it will be gaining a negative charge and will become the anion. So ions and ionic bonds, why are they formed? They are why atoms are making this ionic bond? It is done in order to achieve the octet, as just now I told you. So let us see one of the specific examples where you can see sodium atom and the chlorine atom. Initially, when they are in their neutral form, in their neutral state, there is no any charge on them. So sodium has an atomic number of 11 and its electronic configuration is 2, 8 and 1. So this one electron which is in the outermost or the valence shell will be required to be ejected out, and there are just 7 electrons in the case of chlorine atom in its valence shell. So it has a requirement to accept one electron so that the octet gets completed. So now the condition arises that sodium, if it loses this electron, it will acquire the octet, and chlorine, if it accepts one electron anyhow, it then acquires its octet. So this is how they will be able to achieve their octet condition. But as soon as sodium is releasing out one electron, a positive charge gets created on the same, and as soon as a chlorine atom receives one extra electron, now it acquires a negative charge on it, and now it will be called as chloride ion. Now because this is a positive charge and the other is the negative charge, and we all know there is an electrostatic force of attraction between two opposite charges, and which are strong also, therefore they will lead to the formation of a compound which will be called as sodium chloride. They will no longer be existing in their individual forms. They will now be forming the compound or a molecule over here, and that will be named as sodium chloride, as in this case. This is another way of representation how you can show the electron transfer. So from sodium, one electron being transferred to a chlorine atom, leading to the formation of a sodium ion and chloride ion, which further interacts with each other and lead to the formation of sodium chloride. Okay, so this is one of the things which you should be knowing, that the compounds that contain ionic bonds, they promptly dissolve in water. Why is it so? Because they get a medium to get ionized once again. Immediately, if you are taking sodium chloride, they will get again they will be forming sodium ion and the chloride ion. So that is how it will be done. This is dot and cross diagram. This is the example of magnesium oxide. Here the electrons, how are they arranged, has been shown. This is the magnesium ion and this is the oxide ion. So in magnesium, after losing 2 electrons, there are 8 electrons in its valence shell, and in oxygen, after accepting these 2 electrons from the magnesium, it becomes the oxide ion. So just remember, after it has accepted the 2 electrons, it is no more oxygen atoms. You cannot call it as oxygen ion. It becomes oxide ion. So remember these terminologies as well. Same ways for sodium chloride, you can see this is sodium. Once it has lost one electron, one positive charge is indicated here, and this chlorine, after accepting one electron, gets a negative charge over it and becomes the chloride ion. And as you all can see, the electronic configuration of sodium ion is 2, 8 with a positive charge, whereas for the chloride ion is 2, 8 and 8 with a negative charge. Okay, so in this case, just a second. Okay, I hope it is visible now. So in this case, if you would all see that when there is an atom which is ready to lose 2 electrons, but the atom which is there to accept just 1 electron, so there will be an involvement of 2 individual atoms which are ready to take up one electron each. So as in this case, you can see this is the example of where the formation of calcium chloride will take place, wherein calcium is ready to donate 2 electrons for achieving its octet, whereas chlorine atom can just take up one electron so as to complete its octet. One single chlorine atom cannot take up two electrons. So now here in this case, two chlorine atoms will come and accept one electrons each from this calcium ion, and therefore there will be an interaction between the calcium ion with both of the chloride ions, and therefore there will be the formation of the compound which will be called as calcium chloride. So here are a few definitions which you can actually remember. Ion, an atom or a molecule that gains or loses electrons, and that means it acquires an electrical charge. Atoms form cations which are positively charged when they lose the electrons 1, 2 or 3, or they may be anions with a negative charge when they are gaining electrons 1, 2 or 3. Second thing which is very important, that ionic bonds are strong bonds which are formed when oppositely charged ions are attracted to each other, and they are non-directional, and that which means that ions may be attracted to one another in any direction. There is no any specific direction in which this bonding would be taking place. So example here you can see atomic radius for sodium and ionic radius for sodium, then for chlorine and for the chloride. So definitely you will be able to see that ionic bonds are very strong bonds, and it will be very difficult to break these bonds because there is a strong intermolecular force of attraction between these electrostatic force of attraction between these particles. Now this is the part of NCRT which you will be finding in your books. So I have covered up all the things in the previous slides. These are the electronic configuration, and just remember that every atom tends to attain its nearest noble gas configuration, and because of which they acquire the tendency either to lose the electron or to accept the electrons. I'm just explaining you with the help of an example. Suppose if I talk about magnesium. So magnesium has the nearest noble gas which is neon. So it will try to attain the electronic and configuration of neon rather than argon. So therefore it will try to lose these two electrons, and same cases will be going on with the case of sodium as well as aluminium, which have 1 and 3 electrons respectively. So once they have lost these electrons, they will become positively charged, or the cations, and they will be ready to interact with any of the negative ions, such as the phosphide ion, where it will be accepting these 3 electrons, or maybe sulfur, which will form the sulfide ion, which is S2 minus, or the chloride ion, which is Cl minus ion. So that is how the interaction between the ions go on, and they are forming the bond which is called as ionic bond here. This is one of the example what I discussed in my previous slide also. So that you will show, if you are asked to show the formation of sodium chloride through the ionic bond formation, you will show how the electrons are being transferred. Now one important information for everybody, you need not to show all the electrons which are existing in a particular atom. If you are just showing the valence electrons, that means the electrons which are existing in the last shell or the outermost shell, it will be okay if you show that. So that is how the sodium chloride will be formed in this case. Similarly, for magnesium chloride, you can see magnesium losing 2 electrons, forming magnesium ion, that is magnesium cation, and this 2 electrons will be accepted by 2 of the chlorine atoms each, and then they will form the chloride ion. And that is how you will be able to show the structure, how the formation of magnesium chloride will be done. Now there are few of the properties of the ionic compound. Let us see them one by one. The very first is the physical nature. So you will find the physical nature of these ionic compounds are generally solids, and they are somewhat hard because they have a very strong force of attraction which is between the cations and the anions, and they are generally brittle, and if you are hammering them, they will break into pieces. And I hope everyone is able to understand what do we mean by ionic compounds. All those compounds which have the presence of ionic bond in them are called as the ionic compound. Second is melting and boiling points. So generally it is found that the ionic compounds have high melting and the boiling points. It's just because that they possess a very strong bonding. So the amount of energy required to break these strong interionic attraction is quite high. And because of which it is found that the melting and the boiling points are generally high in them. When we talk about the solubility, these electrovalent compounds, electrovalent means ionic compounds. So they are generally soluble in water and they are insoluble in solvents such as kerosene, petrol, because here they are not able to get ionized, and that's why they are not able to get solubilized with them. Now, the fourth point, which is very important, that is the conduction of electricity. So, if you will be required to identify and differentiate between an ionic compound and like ionic bond and a covalent compound, so if it is able to conduct electricity, then it is an ionic compound, and if it is not, then it is a covalent compound. How? Because the ionic compounds are able to ionize. They are able to get dissociated into respective ions, and because of which there is a formation or the presence of free electrons, which will enable the electric current to pass, and therefore the ions are able to move freely and there is a conduction of electricity, which will not be so in the case of the covalent compound. So these are few of the important properties as far as the ionic compounds are concerned. Now the next topic which we are going to discuss very quickly is the corrosion. So corrosion is a very common term which we all know, I think. And when it is talked about corrosion, the very first thing which comes into the mind is this: some iron material getting undergoing corrosion. So when it comes to iron, particularly, the process of corrosion is termed as the process of rusting. Right, so we will talk about, and this is one of the another very common picture you all must have seen, basically related to the copper and the different materials made up of copper. So what is the corrosion of metals? It is the gradual destruction of material, which is usually metal, by the chemical reaction with its environment. So rusting is one of the type of corrosion where the formation of iron oxide. It is well-known example of electrochemical corrosion, and this type of damage typically produces oxides or salts of the original metal. Corrosion can also occur in the materials other than metals such as ceramics and polymers, etc. Although in this context, the term degradation is more common. So these pictures which you all can see on your screens, when the metal is exposed in the open atmosphere, is quite common. So corrosion around us, metals exposed to seawater will generally get corroded more easily. Ship hulls, which is inside and outside, drilling rigs, oil platforms and other equipments which are exposed to highly conductive marine environments must be protected in some manner. So these are few of the examples where we find corrosion is happening all around us. This is what we discussed just now. Examples of corrosion: rusting, where that iron material is coming in the contact of water and oxygen and getting oxidized to ferrous iron, and therefore leading to the formation of its oxide, which is hydrated ferric oxide actually. So this is how it is going to take place, and the metal will get degraded over the years. Although it is not a fast process, it is a very slow and gradual process which will take a lot of time. But otherwise, if over the years this process is able to get done, and it is going to completely destroy that metal on which this corrosion process is happening. This is one of the another common picture you all must have seen one or the other time. So if I need to represent this particular rusting process, you will find that Iron is undergoing reaction with oxygen and water and leading to the formation of rust, which is Fe2O3 dot H2O, which is actually hydrated ferric oxide. Okay, so rust is chemically hydrated ferric oxide. So in any case you are asked about the chemical name of rust, you can always talk about it, which is hydrated ferric oxide. Please remember this reaction. This is a copper coin which you all can see on your screens. So there is a greenish colored coating which has been formed over the years. So what is this actually? This is again a process of corrosion. So you will find that what is the reaction happening here. In this case, copper is undergoing reaction with water, carbon dioxide and oxygen. Altogether, these three things are called as moist air. And it is forming basic copper carbonate, which is CuOH whole twice dot CuCO3. So, I mean, you can write it this way, or you can simply write it in the form of complex. So, this green colored coating which is deposited on the surface of copper vessel, which is present on the copper vessels, is basic in nature. And there was a question also in your textbook that why do we clean it with something which is sour in taste or which contains some acid, so as to neutralize the effect of this basic copper carbonate. So just remember, this reaction is very very important and you need to remember this. Now when it comes to aluminium, you all know that aluminium is one of the highly reactive metal, but still it does not undergo corrosion much. Why is it so big? It is so because of the protective oxide layer formed on the aluminium. How is it formed? Just see. Why doesn't aluminium corrode? It's a very reactive metal, however does not corrode in the presence of oxygen. Why is it? As you all can see in the picture also, there is oxygen which is present in the atmosphere. Once aluminium comes in the contact of the oxygen, it immediately forms the oxide layer. So the outer aluminium atoms react with oxygen in the atmosphere and forms a thin layer of aluminium oxide on the metal surface, which protects the metal from further corrosion, and therefore there is no further degradation of the same and the metal remains protected later on. Now, this is also one of the very very common form of corrosion, wherein you can see if there is a material made up of silver, like as in this picture, polished silver, and the other one is the tarnished silver, means once it has undergone the process of corrosion. But again, the process is quite slow and gradual. So what is happening in this case? In this case, silver is undergoing reaction with hydrogen sulfide, which is one of the part of our atmospheric gas, and oxygen, and it is getting formed to aluminium sulfide, which is black in color or blackish gray in color, and along with that there is a formation of water which goes into the atmosphere. There are few of the metals which you can see before and after when they are pure and after they have undergone corrosion. The first picture is of copper. This is how it looks like after undergoing corrosion. Second is the lead. This is how it looks like when it has undergone the process of corrosion. Aluminium after undergoing corrosion. Then iron. This is how this will look like. There will be a brownish color substance which will be formed, and silver after undergoing corrosion will be appearing in this manner. So this is how the corrosion will be actually degrading and just destroying the whole metal gradually. What are the different preventive measures? There can be certain measures like painting, one of the common one. Then after galvanization, then you have alloying, you have electroplating, then after you have anodizing, then there is cathodic protection, and then there is enameling. So these are few of the common methods by which you will be able to find that we can protect or prevent the corrosion process. This is the part of NCRT which you will find in your books. There is an activity just to prove this, that when what are the different conditions required for the this rusting process to happen. So in this case you will find that like iron is undergone rusted because there was presence of water and air. In this case there was no any presence of air because there was a protection due to layer of air which did not allow this metal, iron metal, to come in the contact of the air. So there was no corrosion in this case. Similarly, in this case, there was some anhydrous calcium chloride was put up as a drying agent so that whatever moisture is still present in the test tube can be dried up, and there is a dry air. So in this case also there was no any rusting observed. So it proves that oxygen and water, they both are essential conditions under which the process of rusting will be taking place. So these are few of the things which I have already discussed. So you can see there is one important thing. Pure gold, known as 24 karat gold, is very soft and it is therefore not suitable for making jewelry. It is alloyed with either silver or copper to make it hard. Generally in India, 22 karat gold is used for making ornaments. It means 22 parts of pure gold is alloyed with 2 parts of either copper or silver. So that is how we will we come to the end of this chapter. Hope you are able to understand it and there is no any confusion further. Please go through all the NCRT content, whatever has been discussed, and practice for all the different questions which are possible. And also please go through this small paragraph in which it has been discussed about the alloys, the different examples of alloys wherein different metals and the non-metals can be mixed together in a certain proportion to prevent the process of corrosion or to make a different variety of the like substance which is called as alloy. Like an example here, if mercury is the metal, then the alloy of the same is called as amalgam. So here we will find few examples of alloys: brass, which is an alloy of copper and zinc; bronze, which is an alloy of copper and tin. They are not the good conductors of electricity, whereas copper is used for making electrical circuits because it is quite a good conductor of electricity. Solder is an alloy of lead and tin, which has a low melting point and is used for welding electrical wires together. So each and every line of NCRT is important. Please go through it, and in case of any doubts, please get back to your teachers for sure. We will definitely be helping you out. Thank you, and that's all for today. Jai Hind everyone.